Hello, my name is Brady Bauer, and this is my MAE 215 final project. So for this project, what I wanted to do is develop a MATLAB-based automated optical inspection system, or AOI system for short. And what an AOI system does is it's really a tool that's used quite a bit in manufacturing, especially electronics manufacturing, that make sure that the things that come off the production line are up to the customer specifications and are up to all the IPC standardization for PCBAs. So what I wanted to do is just build a really crude AOI system that just works, so I could play around with the functionality and kind of sort of develop my own thing. And what I wanted to do this around is another project of mine that I've been working kind of on and off on for about a year now, that eventually I want to put into production, but it will eventually be a digitally controlled safety lighting system for a bike. And this was the first prototype. It's pretty ugly. There's a lot that's changed since then, but you get the point. It's a blinking light, not super complicated, but it could potentially, once more things get added on to it, it could use a factory test of some sort, maybe. So that's why I decided to build the system. And to just test it, I built a deconstructed version of this, so only 12 of the 20 LEDs in the array are installed. And it's also, the board's been modified, so I've routed all of these to a microcontroller so it can individually control each of these LEDs. And then that microcontroller also has little guy right here. So it's a photoresistor, if you can't see, and that is part of a voltage divider that feeds into this analog input here. And basically what's going to happen is these lights are going to turn on, and when the light turns on, it'll take a reading and then shoot that reading over through serial to MATLAB, and then we'll do data processing with MATLAB. But right now it's working great. I'll just show you real quick what the test actually looks like. So there it is right there. It's less than a second. It's extremely quickly happening. So we have like this is just a measurement I took earlier of one of the pulses. And it's about a 10 millisecond pulse. So it's very quick. Data rates right now, it's a little bit over like 50 hertz, which doesn't sound like a lot, but compared to a person manually looking at this and trying to decipher whether or not everything's working, it's working quite well. So enough of the boring stuff. We'll go into MATLAB here and actually run it. The little green button and get a fancy graph. So, button. Start it. Serial's being a little weird. There's still some bugs I gotta work out. But here we go. So makes a figure, and to help kind of understand what this figure is, it looks a little bit weird, but basically what's happening is you have your baseline brightness value, which is just an analog reading. I picked it to be about 530, which is where it's at with all the ambient lighting in the room and with nothing, or with an LED on. So that's where all of our values should be. And then these bars below and above are 100 units outside of where it nominally should be. So this is kind of our room for pass rate. So if any data point falls in this region, it's good. So all the data points, the way it works is the data comes in and it gets stored in this big row vector where all of the values are stored there, and then later on it gets sorted out into values that are passing spec and values that are not. And the values that pass spec are plotted in green here. So, we can go in and we can see the actual index. So like LED 2 is this brightness value and it's green, it's within spec. But all of the bad ones are plotted in red, and you'll see that they actually fall outside of the margin. So I'll go ahead and just demonstrate what happens with a failure. So just disconnect that. We'll just simulate a failure. You'll see these have been twisted together because this is my second take. But we'll just simulate a failure, you know, say the LED got put in backwards or wrong resistor value, whatever. These wires got cut. The second and 10th LED are now fully electrically disconnected. So we should be able to pick that up with our program very quickly and easily decipher which LEDs are wrong. So we'll just run this again. Oh, it's not plugged in. That's important. So we'll run it. Go. And we got another figure. So this one, you can see red. That means that things have failed. So looking at it, you can see my bars are pretty close to those actual data points. So I could probably move this bar up a little bit. But yeah, you can see there are two very distinct failures. There is this one here, which if we hover over it, you can see that is pin 2, or not pin 2, but LED 2. And very quickly say, oh, that one is not good. Something's wrong there. And same thing with this one. This is just like I said before, LED 10. You can see that something's wrong there. So from here, we could, you know, make some notes, send this over to our electrical test person, and then get it reworked so that we can fix this device just by doing a little data analysis and making the whole process a little bit more accurate and a little easier and extremely fast. So anyway, that is my project. There's a lot of things I could improve on this, and I probably will. It was really fun to work on, but hope you enjoyed. Thanks for watching.